that it's 80. And of course, this affects the age of the universe quite a bit. Today, we think the universe, the Big Bang model says the universe is quite a bit younger than it was when they said this 25 years ago. No inflation. It came about in 1981 and wasn't generally accepted for a few years after that. So inflation's been around about 15 years. No inflation at all in the model of 1980. There was no string theory. I haven't even mentioned that. But this is this idea that there are multi-dimensions to the universe. This has been suggested by particle physicists. There are like 6 extra dimensions that we don't see. And in the early universe, those extra dimensions would have been present, and they've invoked string theory to explain a number of things in the Big Bang, as well as in particle physics. Now, again, there's no evidence for string theory. We haven't been able to build particle accelerators yet to check that. I think it has a little better footing than inflation has, but until we actually get some predictions and some experimental results, it's not entirely a scientific idea now, is it? But string theory wasn't even used, invoked 25 years ago. But now, if you're going to do a Big Bang model today, you better fold string theory into this as well. Dark energy, as I said, that was really revived just 5 years ago. Even 6 or 7 years ago, nobody would dream of putting this kind of term into their Big Bang model. Certainly, again, not in 1980. And dark matter wasn't really considered back as early as the 1930s. There were suggestions of dark matter. It didn't really get any kind of widespread support until the 1970s and then forward 80s and 90s. But in 1980, nobody was really putting dark matter into Big Bang models. That's been more recent than that. So how much confidence did they have back in 1980 in the Big Bang theory at that time? Well, I'll submit to you that it was 100% confidence. They thought the Big Bang model was unassailably true. How much confidence do they have in the Big Bang theory here in 2005? Absolute confidence. How similar are the two models? There's almost no similarity. I mean, the fact that the universe began suddenly and sometime finite time in the past and it's expanded to where it is today, that's about it. Other than that, the details are terribly different. And I'd submit to you that if a theory is that moldable, if it's that you can morph it that easily, and you can invoke any sorts of ad hoc hypotheses to explain any and every new bit of data, it's not really a very good model at all, not a very good scientific model. In other words, a theory must be falsifiable. You must have, at least in some level, the possibility that you could do an experiment or make a measurement that would invalidate the theory. But the rules for the Big Bang seem to be, no matter what new things we find, we will make something up to explain it within this paradigm. And it begins to sound like biological evolution, because it is, I think, the ultimate evolutionary model. I'll end with this. This is the Hubble Deep Field, made back in 1996. is like 100 and some hours of exposure made with the Hubble Space Telescope. They picked a little tiny spot of the sky where there weren't any noticeable stars of any brightness at all. They turned this telescope, the Hubble Space Telescope, on it for an incredibly long period of time, and nearly every object you see in that photograph is a galaxy. Too far for us to measure any kind of distance, usually, or even a redshift on it. There are about 1,600 galaxies found in this little, incredibly small speck of the sky. I've heard, I need to check this out, but I've heard it covers a part of the sky no bigger than the grain of sand held at arm's length. So you get an idea just how tiny this little spot in the sky is. It's very small. And yet we see 1,600 galaxies here virtually at the edge of the universe. Now, if you look down in the lower left portion, there is one star showing up there, and it's got kind of a spike around it, some galaxies. A few years ago, they noticed an object when they went back and did this again in 2002. On the right is a reproduction of 2002, and on the left is 1995, the original photo. And you can see there's an extra object in the image on the right. It's a little red object there. That's a type 1A supernova. A type 1A supernova is a very powerful method of finding distances. And so we're able to get a crude distance estimate for that particular galaxy, assuming that that supernova is inside of that galaxy. And it turns out that the distance of this galaxy is billions of light years away. Not millions, not thousands, but billions. So this galaxy really is a long way away. And one of the big problems we have in creation science today is what we call the light travel time problem. The fact that the universe is incredibly big, billions of light years across, and yet we've only got not 6,000 years to work with, but really only a few days to work with, because I do believe when Adam showed up on the scene on the 6th day, he's able to see those stars. And probably the stars were visible on the 4th day, and I expect that these objects probably would have been visible had you had an HST orbiting the Earth back 6,000 years ago. So we have a problem to explain is how did the light get here all that great length of time? But I see my time is just about expired, so I will let Russ Humphreys or somebody else handle that problem. Thank you very much.